Hey guys, today we're going to do 9-2 and 9-3. 9-2 is arithmetic sequences, and you will be able to define, identify, and apply arithmetic sequences. And 9-3 is geometric sequences, and you will be able to define, identify, and apply geometric sequences. First, we're going to start with 9-2, which is arithmetic sequences. And this is a sequence where the difference between consecutive terms is constant. This difference is called our common difference. So an arithmetic sequence with a starting value A and a common difference D is a sequence in the form of A plus D, A plus 2D, A plus 3D, and so on. We have two different types of definitions. We can have a recursive definition, and we can have an explicit definition. Our recursive definition has two parts. So for our recursive definition, we need to have the initial condition, which is our first term. So A sub 1 is equal to a value. Then we need to have the recursive formula, which is in terms of the term before. So A sub n, which would mean any term is equal to the term before A sub n minus 1 plus D, the common difference. So if we're writing recursive definition, we need both parts. The explicit definition for this sequence is one single formula, and the explicit definition means that we can find any term value. So A sub n, which is any term, is equal to the first term plus n minus 1 times D, where n is the term number. D is our common difference. So is this sequence an arithmetic sequence? What we need to do is find the difference between our consecutive terms. So between our first and second term, the difference is 3, 3, 3, and 3. The way I got that was 6 minus 3, 9 minus 6, 12 minus 9, and 15 minus 12. Since we have the same difference, yes, this is arithmetic. And our common difference, D, is equal to 3. The difference between 1, 4, 9, 16, and 25. 4 minus 1 is 3. 9 minus 4 is 5. We can stop there because the two differences are the same, so this is not an arithmetic sequence. What is the 100th term of the arithmetic sequence that begins 6, 11, and so on? So if we're finding the 100th term, that means we have to look at A sub n is equal to A sub 1 plus n minus 1 times D. And we need all of this information. We can find D by doing 11 minus 6, which is 5, so that's our common difference. We're looking for the 100th term, so n is equal to 100. And we know our first term is 6, so we plug it in. A sub 100, which is meaning the 100th term is equal to 6 plus 100 minus 1 times 5. So 6 plus 100 minus 1 is 99 times 5. 99 times 5 is 495 plus 6 is 501. Therefore, the 100th term, or A sub 100, is equal to 501. What are the second and third terms of this arithmetic sequence? 100 blank blank 82. So we need to find the common difference, so we added D once, we added D again, and we added D one more time. So to get from 100 to 82, we had 3 D's. So I would do 82 minus 100 divided by 3. 82 minus 100 is negative 18. Divided by 3 is negative 6. Making our common difference negative 6. So 100 minus 6 would be 100. 94. 94 minus 6 would be 88. 88 minus 6 would be 82. So our middle two terms would be 88 and 94. Arithmetic mean, or the average of two numbers, x and y, is x plus y is divided by 2. This is the middle term of any 3 consecutive terms. So we could find the average just like we did before. So I could do 15 plus 59 divided by 2. 15 plus 59 is equal to 74. 74 divided by 2 is 37. So that middle term would be 37. Now, geometric sequences. The difference between a geometric sequence and an arithmetic sequence is now, instead of adding and subtracting, we will be multiplying or dividing. So we're going to have a common ratio, which is r, and that's going to be what we're multiplying. Our recursive definition still needs 2 parts, the initial condition and the formula that gives us a term in terms of the term before. And the explicit definition would be a sub n is equal to our first term times r to the n minus 1 power. We're going to divide to see whether or not these sequences are geometric. So I'm going to take 6 divided by 3, which is 2. 12 divided by 6, which is 2. 24 divided by 6, which is 2. 48 divided by 6. I'm sorry, not 6 every time. We would do 24 divided by 12, which is 2. 48 divided by 24, which is 2. Therefore, we have the same number, so r, or our common ratio, would be 2. For b, 6 divided by 3 is 2. 9 divided by 6 is 3 over 2. And then I'm going to stop because 2 and 3 over 2 are not the same, which means this is not geometric. What are the indicated terms of the geometric sequence? So the first, if we have 4, 12, 36, a sub 1 is 4, which is our first term. Our common ratio is, we would do 12 divided by 4, which gave me 3. So we have our first term and we have our ratio. We need to think about our explicit formula, which is a sub n is equal to a sub 1 times r to the n minus 1 power. If we are looking for the 10th term, n is 10. Therefore, a sub 10 is equal to 4 times 3 to the n, which is 10, minus 1 power. 10 minus 1 is 9. You have to do 3 to the 9th power first, which is 19,683. Then times 4, which is 78,732. The second and third terms of the geometric sequence is what we need to find for 2 blank blank negative 54. So 2 times r times r. So that means r to the third power is going to be equal to negative 54 divided by 2. Negative 54 divided by 2 is negative 27. In order to get r, I would cube root both sides, and r is equal to negative 3. So 2 times negative 3 would be negative 6. Negative 6 times negative 3 is 18. 18 times negative 3 is negative 54. The geometric mean between the numbers x and y is the square root of x times y. So if we had 3 blank 12, in order to take the geometric mean, we would do the square root of 3 times 12. 3 times 12 is 36. The square root of 36 would be 6. Therefore, your middle term would be 6. That's all for today.